While we have incredible science for understanding infectious diseases, we have many examples of failed efforts to control an outbreak or to eradicate pathogens completely. Today, we'll cover some of the reasons why control efforts fail and why eradication can be hard. We will limit our discussion to infectious diseases affecting humans. There are biological reasons for failure, such as adaptation on the part of the pathogen. We will focus on human reasons, specifically human reactions and system readiness. The first thing to understand is humans' reactions to directives. Directives, at their best, provide clear, explicit instructions of what someone must do. Directives intuitively follow the medical script of, take 2 of these and call me in the morning. A relevant example for outbreak control, such as quarantine, is the message, you must stay there until I say so. By their nature, directives elicit 2 plausible yet opposite responses. Some people will obey the directive, while others will become oppositional and defy it. Stanley Milgram's experiments provided compelling demonstrations on how authority, even falsely cued through clothing like white lab coats, can elicit obedience. At the same time, on average, 35% of the participants did not fully comply. To be honest, getting 65% of people to do anything can be a victory for a persuasive campaign. For infectious diseases, however, if 35% of people in quarantine try to get out, then we could have a real problem. One reason for defiance is psychological reactance, which is a human motivation to restore freedom when people believe that it is threatened or eliminated. Once psychological reactance is triggered, people attempt to reassert their freedom, and one way to do that is to engage in the forbidden freedom. If we're trying to maintain quarantine, we can put up walls and monitor those walls with armed personnel, as long as we have the infrastructure. To put this into context, 14,000 people were quarantined in Canada and over 130,000 were quarantined in Taiwan during the SARS outbreak in 2003. Depending on the epidemic, there may not be enough resources or personnel to enforce the walls and manage those who don't comply. Resources lead us to the second major challenge, system readiness. As described in another video, eradication often relies on widespread, intense vaccination efforts, followed by smaller, focused efforts to wipe out any leftover pockets or reservoirs of infection. There are 5 broad tasks for vaccination efforts: vaccine development, field testing, scale-up, diffusion, and monitoring. In other words, we need to make a good vaccine, test it, make a lot of it, give it to a lot of people, and monitor who got missed. This leads up to a profound mystery in control efforts. Some infectious diseases have feasible, viable, and effective technological and behavioral solutions. For example, there are some diseases where the vaccines have already been developed and field tested. The problem is some systems, communities, states, or countries do not have the infrastructure, resources, coordination, or personnel to scale them up, diffuse them widely, and monitor for leftover pockets. Infectious diseases, then, may persist even when solutions exist. To recap, we discussed 2 reasons why control and eradication of infectious diseases are difficult in humans: human reactions and system readiness. Of course, changes in the pathogen itself can also make eradication difficult. For example, every year we're trying to recalibrate the flu vaccine to fit the latest data and scientific knowledge. It's likely that human and pathogen responses to intervention efforts interact. This is one reason why interdisciplinary teams can be so important.